All right, let's do this. Welcome to your super fast, laser-focused revision for moving charges and magnetism. We're going to absolutely nail this chapter right here, right now.
Yep, forget flipping through hundreds of pages. Think of this as your strategic playbook. We're covering everything you actually need: the critical formulas, the core concepts, the best way to solve problems, and maybe, most importantly, how to stop losing those easy marks. So, let's jump right in.
Okay, first up, the formula hit list. You know the 80-20 rule, right? This is it. These are the 20% of formulas that are going to get you 80% of the marks. Mastering this short list is seriously your fastest path to a killer score.
Okay, check this out. This is your cheat sheet of heavy hitters. Let's really dig in here. Number one, the absolute king, is the Lorentz force. F equals Q times V cross B. Now for the direction, the right-hand rule is your best friend, always. Fingers point with velocity, you curl them towards the magnetic field, and bam, your thumb shows you the force. But listen up, here are two massive traps. First, if V and B are parallel, the force is zero. It does nothing. Second, and this is where everyone messes up, if your charge is negative, like an electron, you find the direction like normal, and then you flip it 180 degrees. You have to remember that. Got it? All right, number two, the radius of the circular path. It's pretty intuitive, actually. A heavier or faster particle is going to make a wider turn, a bigger circle. A stronger magnetic field, it's going to pull it in tighter. Simple as that. And number three, the cyclotron frequency. The coolest part about this one, it doesn't care about the particle's speed or the size of its circle. It's completely independent of them, which is a key concept. All right, next up, the B field for a long, straight wire. Super simple. The further you get from the wire, the weaker the field. And that field wraps around the wire in circles. And how do you find the direction of those circles? You guessed it, the right-hand rule again. It's your go-to tool for this whole chapter.
So what if you have a whole chunk of wire with current flowing through it? What's the force on that? Well, that's F equals BIL sine theta. The key takeaway here, force is at its max when the wire is perpendicular to the field, and it's zero when it's parallel. See the pattern here?
And to round out our formula list, torque. You put a loop of current in a B field, and it's going to want to twist. That twisting force, the torque, is M cross B, where M is the magnetic moment. And listen, this isn't just some abstract formula. This is literally the principle that makes electric motors and things like the moving coil galvanometer work.
Okay, so we've got the formulas down. That's step one. Now let's talk about the why, the core concept clusters. This is where we move from just knowing formulas to actually understanding how to use them to crush exam questions.
And look at this breakdown. It tells you exactly where to put your study time. A whopping 40% of questions come from mastering the Lorentz force. Another 35%, that's all about Biot-Savart and Ampere's law. And the last 25%, devices. So let's dive into each of these clusters.
So for any Lorentz force problem, just use this simple, foolproof three-step process. Seriously, it works every time. Step one, just draw out your V and B vectors. See them in your head. Step two, whip out that right-hand rule. Find the direction of V cross B. Your thumb gives you the force. And step three, and I'm going to say this again because it's so important. If the charge is negative, you have to flip the direction you just found. Don't be that person who forgets.
Okay, now for calculating B fields. The secret here? It's all about the shape. Just think of this as your geometry pick list. Got a long straight wire? There's a formula for that. A circular loop? Got one for that too. A solenoid? A toroid? Just match the shape to the right formula. It's that easy. Oh, and a quick pro tip. For a perfect solenoid or toroid, we just assume the field outside is zero. It makes life way easier. All right, let's clear up the biggest point of confusion in this chapter, converting a galvanizer. This is it, super clear. Want to make an ammeter to measure big currents? You need to give that current an easy path to bypass the device. So you add a low-resistance shunt in parallel. Makes sense, right? Now, want to make a voltmeter to measure big voltages? You need to protect the device from all that voltage. So you add a high-resistance resistor in series. Just remember, parallel for current, series for voltage. Lock that in.
Awesome. You've got the knowledge. Now it's time to weaponize it. Let's talk problem-solving protocols. This is your game plan, your tactical playbook for when the clock is ticking in the exam.
This is also about managing your time. If you get a Lorentz direction question, give yourself 2 minutes, tops. Write the vectors, use the rule, check the sign, done. A B field calculation? Maybe 3 minutes. Identify the shape, grab the formula, plug in the numbers. For the longer device explanation questions, yeah, you can budget maybe 5 minutes for those. You got to draw the diagram, state the principle, and show the derivation.
Okay, we've talked offense. Now let's play some defense. This is your error prevention checklist. Think of this as protecting your hard-earned marks from those silly, simple mistakes that trip people up every single year. Not gonna happen to you, not this time.
All right, let's do this rapid fire. Run this checklist in your head before you move on from a problem. Did you include the sign of theta? Are you 100% sure you used the right-hand rule correctly? Did you remember to flip the force for electrons? Are all your units in proper SI? Do you know the difference between the field inside versus outside? Does your Amperian loop actually match the symmetry? And did you state your assumptions, like assuming an ideal solenoid? Just a quick mental scan can save you so many marks.
We are in the home stretch now. Let's lock all this knowledge into your brain with some powerful recall triggers and a quick quiz to make sure it sticks.
You know that moment in an exam when your mind just goes blank? Well, here's a simple mnemonic to pull you out of it. Fabric. Just remember the word fabric. It stands for force, Ampere's law, Biot-Savart law, radius of motion, I for current, and C for cyclotron. It's an awesome way to just mentally scan the big topics if you get stuck.
Okay, let's put this into practice. Ready? First question. You've got a proton. It's moving along the positive x-axis. It enters a B field that's pointing along the positive z-axis. So, what's the direction of the magnetic force? Go on, use your right-hand rule. I'll give you a second.
And the answer is the negative y-axis. Did you get it? Your fingers point along x, you curl them up towards z, and your thumb has to point down. That's the negative y direction. And since it's a proton, a positive charge, we don't flip anything. Perfect.
All right, next question. This time, a particle enters the field at some angle, alpha, so it's going to move in that spiral, that helical path. The question is, what's the pitch of that helix? And remember, the pitch is just how far it moves forward in the time it takes to do one complete circle.
So the answer is you take the component of velocity that's parallel to the field, that's v cos alpha, and you multiply it by the time it takes for one full revolution, which is just 2 pi m divided by qb. That product gives you the pitch. It's the forward speed times the time for one loop.
Okay, here's your final challenge. I'm serious. Pause after I say this and really try it. Right now, on your own, can you list the top 5 formulas we talked about? Can you name 3 of those common traps from our error checklist? And can you explain the 2 device conversions? Go on, test yourself. This is how you make it stick.
And that's a wrap. Seriously, in just the last few minutes, you've hammered home the absolute core of this chapter, that 20% of the material that gets you 80% of the marks. You are prepped, you are ready. Now go out there and ace that exam. Good luck.